Dear programmer, are you seeking the methods to control stepper motor? Please find the solution here. Today, we will find the techniques of interfacing a stepper motor with ATmega2560 Microcontroller. For this, we need four things: a computer as development environment, one ATmega2560 Microcontroller acting as the heart of arduino Mega 2560 board, a motor controller containing ULN2003 as motor driver IC, and finally a stepper motor 28BYJ48. Basically, a stepper motor consists of two coils and hence four terminals. Proper sequence of pulsed waveform needs to be applied to four inputs of the motor controller. The waveform advancing in a certain direction generates magnetic flux that drags the rotor for motion. Various states of the waveform in four input lines generate combination of bits. This is shown in adjacent truth table containing 8 different states. The 8 states are shown here through slow transition of LED display, although the switching in actual case is much faster to cause rotation. At this, display appears to be steady. Now, correct pinouts of devices are shown. The supply of controller may come from external power supply in the range of 5V to 12V. Presently, onboard supply is used. The coding with Arduino style is shown here. In setup section, all the microcontroller pins connected to input pins of motor controller are configured as output pins. The truth table is now implemented from any arbitrary state of logic. The organization of program and its entry into Arduino IDE is shown now. The Mega 2560 board is connected to the computer via USB port. In the Tools menu, the board is selected. The COM port assigned to the board is selected also. Then, the program is uploaded by clicking the upload button. First it is compiled, then uploading takes place. To know the details of such interfacing between Arduino board and computer, you can refer one video on LED blinking that has been uploaded previously. If all the states are implemented in reverse sequence, the direction of rotation reverses also. Now, we want to apply rotation for finite number of steps in each direction. The angle subtended by one step of the motor, called stride angle, is 5.625 degree. So, to complete one revolution, 64 steps are required. The number of steps are further amplified by increasing the precision of movement. This is accomplished by gear. A total of 4096 steps are achieved finally. To change the direction of motor rotation, a variable named direction has been introduced in program. Before 4096 steps are completed, direction of rotation is reversed as per the program. The truth table is implemented through switch statement. Alternatively, it could be implemented through if-else structure also. In switch statement, various states are taken through case declaration. Each section of case is executed depending on the variable state. Hence, progression of logic states assigned to the variable state determines the sequence of execution and hence the direction of rotation. Another approach of coding called register level coding is presented now. Here, any bit or pin can be manipulated with less than operator. For example, to set bit 5, one less than 5 is ORed with the original variable or port. To reset bit, its complement must be ANDed with the variable or port. The bit 5 and 6 of port H of microcontroller are used as pin 8 and 9 of the Arduino Mega board. They are connected to in 1 and in 2 pins of motor controller. They are set and reset whenever required. The bit 4 and 5 of port B are used as pin 10 and 11 of the Mega board. They are connected to in 3 and in 4 pins of motor controller. They can be set and reset by the same technique. The steps of program to implement truth table are shown now. The advantage of this method lies in shorter length of program.